Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the angle of contact, meniscus, which you have heard so many times, as well as the concept of wetting and non-wetting liquids. So first of all, let us define the angle of contact, and I'll then explain that why angle of contact is very important in calculating the surface tension force in different cases. So first of all, angle of contact is defined as the angle made by the tangent drawn to the free surface of a liquid at the point of contact of the solid and liquid measured inside the liquid. Okay, so I know that this definition is not enough to make you understand the concept of this angle of contact. So I'll be explaining the angle of contact in detail with these examples. Let us imagine a situation in which there is normal pure water. This is pure water plus glass capillary. So you can first of all, let me explain you that what is a capillary tube. So capillary tube, you have seen that it is a tube which is opened from both the ends. It is just like a open test tube. So it is a tube which is open from both the ends, and it is very thin, which means that its radius is very small. It is almost negligible. So this is a capillary tube. So when we dip some liquid into a capillary tube, and that liquid is pure water plus the tube is of glass, then you will see that the shape of the free surface of the liquid is flat. So this shape is actually called as the flat meniscus. This is also called as the flat meniscus. Okay, and the shape of the free surface of liquid is called as meniscus. So as it is of flatter shape, so it is flat meniscus. So this is also called as meniscus. Now you can see that if I talk about a single molecule of water, then on this single molecule, the molecule of solid, which is glass, is applying adhesive force in this direction like that. And the molecules of the water behind this molecule are spread in the span of 90 degree. In this complete span, the molecules are spreaded. So all the molecules behind this molecule of water will be applying equal amount of cohesive force on these molecules, and due to that cohesive force, a net cohesive force will be developed at an angle of 45 degree with the horizontal, like that. And therefore there will be two equal components of the cohesive force, F1 and F2, and each of them will be equal to Fc by root 2. And obviously this Fa is cancelling out this Fc by root 2, which is F1, and therefore the net force will be this one. The net force acting on this molecule will be this one. And we always know, we have already studied in the fluids that fluid cannot resist the tangential forces, which means that if you will apply some tangential force or tangential strain to the fluid surface, then it will begin to flow. It cannot resist that tangential force. It will begin to flow. So we know this fact. And in the surface tension section, we have already discussed that surface tension is a phenomena of the liquids which are at rest, because there is no liquid film formed on the surface of the liquids which are flowing. So surface tension is a phenomena for the liquids which are static in any frame. Okay, and in this, obviously in this case, we are dealing with the surface tension only, so we cannot make the liquid flow. So we can say that the net force acting on the liquid molecule, which is situated on the surface of the free surface of the liquid, will be in such a way such that the free surface and the net force will be mutually perpendicular. So you can see that this is free surface and it is always perpendicular to the net force because it cannot resist any tangential component of this net force. So there will be no tangential component acting on this molecule along the surface, and hence this liquid can remain at rest. Now this concept is simple and it can be understood by the basic definition of fluids, which I have already explained. And we can also say that in this case, if we keep a water droplet of pure water and on a glass surface, then this droplet will take this shape of U shape and this angle will be 90 degree. And in this case, if we draw a tangent like this on the free surface of the liquid, and if at the contact point, and if we measure the angle of this tangent with the solid surface inside the liquid, see there are two angles. One is this and the other one is this one. So we have to measure the angle which is inside the liquid. So this angle is 90 degree. So we can say that the angle of contact is the angle made by the tangent drawn to the free surface of the liquid at the contact point with the solid surface measured inside the liquid. Okay, I feel that now you would be getting this definition correctly. And in this case, obviously, this meniscus will be a straight one and this will be the flatter meniscus. And now if we discuss that this contact angle for this case of liquid is 90 degree and it is for pure water and glass capillary. But if we take another situation in which we see that the net cohesive force is in this case the net cohesive force is applied by the molecules which are in a greater span. These molecules were in the span of 45 degree and these molecules are in a span of angle which is greater than 90 degree. This angle is these molecules were in a span of 90 degree. So these molecules are in a span which is greater than the 90 degree. Therefore we can say that the net cohesive force will be like this, and hence it would be more closer to the horizontal direction, and therefore we can say that this component F1, which is the horizontal component of net cohesive force, will be greater than the adhesive force acting on this molecule. And therefore the net force, which is the resultant of all of these, will be like this, and this net force F net will be equal to under root of F1 minus Fa whole square plus F2 square. This will be the net force. And obviously as this net force is acting in this direction, the free surface will align itself perpendicular to this net force, and therefore this angle will be the 90 degree angle. Okay, you can see that this angle will be 90 degree angle. This angle I'm talking about. Okay, and this if we keep this kind of liquid drop on a glass capillary surface, then this drop will take a shape of this one and this angle will be greater than 90 degree. And this realistically happens in the Hg plus glass capillary. Okay, this is Hg plus glass capillary. Okay, and this meniscus is also called as upper meniscus. This is also called as upper meniscus. This is upper meniscus. And in this case, obviously angle of contact is greater than 90 degree. And in this the case, first case, in which we can see that the cohesive force is uh, spread in the span which is less than 45 degree. So we can say that the net cohesive force will be more inclined towards the vertical direction, and hence we can claim that F2 will be greater than F1. And in fact, FA will be greater than F1, and therefore the resultant of all these forces will be in the outward direction. This is F net, and F net in this case will be F net will be under root of Fa minus F1 whole square plus F2 square. These two net forces will be equal in magnitude, but the direction will be different. And therefore you can see that the free surface of the liquid will align itself in such a way such that the net force will be perpendicular to this free surface, like this. Because obviously we have already discussed that the liquid at rest cannot resist the force which is tangential to it. And obviously this liquid will be at rest definitely, because this is the case of surface tension which dominates in the static liquids only. So now if we pour the drop of this liquid on a normal glass on a glass surface, then this drop will take this shape and this angle of contact will be less than 90 degree. You can see that if we draw a tangent at this point on the surface, and if we measure the angle of the tangent with the solid surface in the liquid, then this angle will be less than 90 degree. So this happens realistically in normal water plus glass capillary. Okay, this realistically happens in this case. And the meniscus it forms is also called as the lower meniscus. If we draw it, then it is also called as the lower meniscus. This is the lower meniscus. Okay. And in this case, angle of contact is less than 90, it is greater than 90, it is equal to 90. So let us also discuss that if that angle of contact of any liquid with solid is either less than or equal to 90, then it is called as wetting liquids, which means that these liquids gives a wetting sensation when we touch it. And this is due to the fact that in these kind of liquids, cohesive force is weaker and adhesive force applied by our skin molecules on the liquid molecules is greater than the cohesive force applied by the liquid molecules on the other molecules. And therefore these liquid molecules are absorbed inside our skin, and they give us the sensation of wetting liquids because they are absorbed inside the skin till our sensors, the skin sensor, touch sensors. But in the case of mercury, the cohesive force is so strongly dominated, and it dominates the adhesive force applied by our skin molecules on the mercury, and therefore mercury is not absorbed inside the skin, and therefore it cannot reach the touch sensors of the skin. Therefore we cannot feel any wetting sensation when we touch the mercury. So obviously when theta is greater than 90 degree, then this is called as non-wetting liquids. Okay. And there is another thing which is also called as capillary action. So you must have studied in class 10th or 9th that the roots of the plant performs capillary action. They absorb the water from the ground and they apply a greater adhesive force on the water molecules, and they transport that water to the leaves to perform basic actions for growth of the plant. And in the same way, you must have heard about the lantern, which is laltain called in Hindi, which is used in the villages in today world also. So you must have seen that there is a flame which is burning a cotton which is dipped in kerosene at the bottom. So this cotton thread is soaking up the kerosene to the flame, and the flame is burning the kerosene here. So this is also a capillary action in which the cotton molecules are applying a stronger adhesive force on the kerosene, and they are transporting this kerosene at the top for flame burning. And you must have seen that there is a knob with which we control the light, amount of light produced by this lantern. So what we do, that if we rotate this knob, then the area of the flame, area of the cotton is pulled outside, and therefore more area is available for burning. So the flame increases and the luminous intensity increases. If we have to decrease the light, we pull this flame with this cotton inside. So the effective area of burning of this cotton decreases, and the amount of light produced by burning also decreases. So by this means we have, our ancestors have already produced a variable luminous intensity device which is not operating on electricity. So this was it in this video, and in the next video we'll be bringing some more interesting concepts on surface tension. Thank you.